All right, we're ready to start our second part of Chapter 6, Becoming Acquainted with Statistical Concepts. This will be a little bit shorter lecture. All we're going to talk about in this lecture is ways to select a sample, which will be pretty extensive, and basic concepts of statistical techniques. And again, if you, I have put these PowerPoint slides in the Blackboard uh, e-lesson. If you want to just print out the PowerPoint slides so you can follow along, because I know it looks a little small inside of iTunes. All right. So we have to understand some terminology, because in the long run, if you're doing a study, you're going to use people and use a small portion of those people to do your experiment or your study on. There's some terms called population and sample that we need to be aware of. I use the definitions from other research methods textbook by Cresswell. And so a population is a group of individuals who have the same characteristics. For example, we can use a characteristic of male basketball athletes. We'll say the population is every single male basketball athlete in the world. So that's a lot of individuals. And we can further say that the population can be college male basketball athletes. So any male who is playing college basketball athletics is a population. But then we have a target population, which would be a group of individuals or or a group of organizations with some common defining characteristics that the researcher can identify and study. So a target population, we used our big population as college male basketball athletes. Our target population can be male college basketball athletes at the NAIA level, or we can say Division One, NC2A D1, or NC2A D2, whatever way we want to delimit that population. That's the target population. We're only going after those particular individuals. So again, a population is the big thing, and really, population can be everybody in a world. We're giving them specific characteristics, male college basketball athletes. Target population would be NAIA male basketball athletes. Now, what a sample is a subgroup of the target population that the researcher plans to study for generalizing about the target population. So a sample is, let's say we want to do a study where our group of individuals is going to be NAIA male basketball athletes. We're going to use, we're not going to be able to use every single NAIA male basketball athlete. So we're just going to grab a sample of those individuals. And what we're going to say is, because we've done a study, we've taken a sample out, a chunk out of that target population, that after we run our study, determine if we're going to accept or fail to reject or reject the null hypothesis. Let's say that we do the study and we reject the null hypothesis, and what that says is, whatever that null hypothesis was, is that our study made a difference. And then what we can do, in the term there, it says generalizing. What generalizing means is that we can take the results from our study and say that based on our study, we can say, generally speaking, that this is true of the target population. Whatever we found about this sample is generally true about the target population. Again, let's talk about medicine studies for cancer research. They take a small sample of the population, which is, let's say, cancer research. So they take a small sample of cancer patients, give them some do some treatment on them, give them some medicines, and we'll talk about the design of the study later. They do their study, and they reject the null hypothesis. It means that the medicine worked, and so then you hear on TV, it has been found that XYZ medicine will help cancer treatments because they're generalizing the results about their sample back to their target population. So this picture kind of shows again what I just said in words. We have the big circle there, which is our target population. Then we're going to take a sample out of that. We're going to pull a small sample out of that target population, and then that smaller sample is how we're going to run who we're going to run a study on. So down there in the words, it's all teachers in high school in one city would be the population. Then his sample is all high school biology teachers. So it's going to be a smaller group. College students in all community colleges. Then our sample is students in one community college, so forth and so on. Um, it's pretty straightforward. There are some ways to select a sample, some correct ways. The first one is random sampling, and in the textbook, I believe it is in Appendix A, there is a table of random numbers, and I'm going to go over these ones in each detail. We have a stratified random sampling, systematic sampling, random assignment, justify and poke hoc, and how good does it have to be. So we're going to be talking about these as we go along. Okay, so simple random. Random is, again, it's just like the word, you're just kind of random. You're not really trying to have some kind of method to it. So we select the sample from the population, so all the population has an equal chance of being selected. Easiest way for me to explain this, I remember when I took a statistics course and where we're talking about probability. The teacher gave all of us M&M bags, and then we had to pull out all M&Ms, count all the M&Ms. Let's say there's 50 M&Ms in the bag, and then we put all the M&Ms back in the bag, and we had to select a sample from that population of M&Ms. We had to select 10%, so 5. And all we do is stick our fingers down there and pick out one at a time to be our sample. That's a random sample. Everybody had the same opportunity to be in the study, for example. And another way, if you have your textbook, I just mentioned a little while ago, is random tables. In Appendix A, which is on page 406 in the textbook and continues on to page 407, there's a table of random numbers. And what that does is you say that you're going to pick so many people, say a percentage of the population. You close your eyes, stick your finger on a number, like I picked 85, and you start at 85, you're going to pick, you have all your subjects and numbers. You don't know who they are, you have a number, and you're going to pick subject 85, 44, 20, 58, so forth and so on. So each individual has equal chance of being selected. For true experimental design, we need to use random sample. Next type is systematic, which is similar to actually what I just said, is choosing every nth individual or citing a population until the desired sample is achieved. So you say you're going to choose every ninth individual. You have a list of 150,000 people, whatever number you get from your population, you choose every ninth individual. So that's systematic sample. Another type of sampling is called multi-stage clustering sample. A sample is chosen in 1 or 2 stages because a population is not easily identified or large. So you have a smaller group, You pick one group of subjects. Uh, let's use the basketball analogy again. We got the target population of male basketball athletes. We go down to the NEIA. Um, that's one part. You're going to identify NEIA. Then you decide I'm going to pick just the West Coast NEIA schools. Then out of those West Coast NEIA schools, you're going to choose 5 from one conference and 5 from another conference, just as an example. Another method of choosing samples is stratified sampling, stratifying the population on a characteristic, for example, gender, then sampling from each stratum. So I kind of did this with mine, and a little bit, mine was more convenience, which we'll talk about in a little bit, where I can choose, maybe I just wanted to select female athletic training students. Then from there, I kind of just select out from there. Then another, what this picture is showing is proportional stratification sampling approach. So we have a population of 9,000. That's what the N stands for in statistics. N equals the number of subjects. Then from there, we're going to say we want 600 boys or 6,000 boys and 3,000 girls. So we want 66% of our population and 33% of our population. Let's say that the reason why you're doing that is that you found in some particular setting that there's a certain population of males to females, and so you want to make sure that your study is proportionally correct to the normal distribution of your population. So that's one reason why you might choose that. So at the end, they have 200 boys in their study and 100 girls in their study, and a total sample of 300. A couple more ways to sample is called convenience sampling. You are selecting your participants are selected because they are willing and able to be studied. You ask them, and they're, yeah, I can do that. It's not the best way to do it. You have some bias going on with that. Pretty much everybody in this graduate program is using convenience sampling just because we need to get it done. That's what I did for my dissertation. And so most of you will probably end up using convenience sampling. There's nothing wrong with it. It's better to have random sampling. That's the best method. Another method is called snowball sampling. The researcher asks participants to identify other participants to become members in a sample. You ask Joe, Joe asks Jill, Jill asks blah blah blah, and it just keeps going. It's not the best way to do sampling, but sometimes you just have to get participants. Now the question is, how large should our sample size be? Obviously, as the first bullet says, as large as possible to lessen sampling error, because sampling error is basically, we want to make sure that our sample is really the same as our population. And the more people we have that represent that group, the better off we'll be. And again, sampling error limits the generalizability of the study. If we don't really have a sample that's really like the population, then the results we find will not be able to go back and say that for the most part athletic training students believe this, or a basketball player does this, or a coach does this, medicine does that. We want to make sure that we have good samples of how people generally behave or react. But these are pretty good techniques to use for research, these numbers. You basically would like to have approximately, on a minimum size, 15 participant in each group of an experiment. And when we get to experimental design, we'll talk about that. Typically in an experimental design, you usually want at least 3 groups. You want Group A, which is doing one thing, Group B is doing another thing, and you want Group C, which is a control group, which does nothing. And so you would need 15, a minimum of 15 in each one of those different groups. Now, for a correlational study, we are comparing a variable A against a variable B. It would be nice to have 30 participants in that study. And again, these are minimum numbers, not if you have more, that's great. For a sample, 350 individuals is good. And in reality, we'll talk about survey research here in a week or two. Well, maybe it's next week. If you send out 1,000 requests for surveys, you'll be lucky if you get 10 to 20%. So I think on my dissertation I had 259 responders. I don't remember how many I sent out. I didn't actually get that, but it was close enough. There are sample size formulas. I believe I've put some of those formulas or links on the internet where you can go to the websites and you can actually calculate the numbers. And in reality, it's just who you can get for this research project study that you guys will be doing.